researchers discover gene behind sixth sense in humans. A soft brush that feels like prickly thorns. A vibrating tuning fork that produces no vibration. Not being able to tell which direction body joints are moving without looking at them. Those are some of the bizarre sensations reported by a 9-year-old girl and 19-year-old woman in a new study. The duo, researchers say, shares an extremely rare genetic mutation that may shed light on a so-called sixth sense in humans, proprioception, or the body's awareness of where it is in space. The new work may even explain why some of us are kludsier than others. The patient's affliction doesn't have a name. It was discovered by one of the study's lead authors, pediatric neurologist Karsten Bonneman at the National Institutes of Health, NIH, in Bethesda, Maryland, who specializes in diagnosing unknown genetic illnesses in young people. He noticed that the girl and the woman shared a suite of physical symptoms, including hips, fingers, and feet that bent at unusual angles. They also had scoliosis, an unusual curvature of the spine. And, significantly, they had difficulty walking, showed an extreme lack of coordination, and couldn't physically feel objects against their skin. Bonneman screened their genomes and looked for mutations that they might have in common. One in particular stood out, a catastrophic mutation in piezo2, a gene that has been linked to the body's sense of touch and its ability to perform coordinated movements. At about the same time, in a very lucky accident, Bonneman attended a lecture by Alexander Chesler, a neurologist also at NIH, on piezo2. Bonneman invited Chesler to help study his newly identified patients. It wasn't the disease's rarity that so shocked Chesler when he met the girl and young woman, it was the fact that when scientists had previously knocked out piezo2 in mouse models, it had always proven fatal. Most assumed people couldn't live without it, either. The researchers performed a battery of tests with the patients and a control group. When blindfolded, the patients staggered, stumbled, and fell. But with the blindfold removed, they could walk almost normally. The patients also performed a task when they moved their index finger from their nose to a target placed in front of them. Blindfolded, they failed miserably. Eyes uncovered, they did well. The researchers held the patient's arms and moved the joints either up or down, asking them to indicate the direction. Blindfolded, they couldn't tell which direction their joints were being moved. No blindfold, and, naturally, they could tell just by looking. Together, the tests suggested the patients totally lacked proprioception, the researchers report online today in the New England Journal of Medicine. Healthy individuals rely on the sense to perform a variety of tasks like playing the piano, shifting gears in a car, or typing on a keyboard, Bonneman explains. Doing these things requires awareness of one's limbs in space. The patients lacked this instinctual awareness, but were able to largely compensate for it by watching their limbs. The researchers also tested the patients' responses to a variety of touch tests. In one, the girl and woman could not sense the vibrations of a tuning fork pressed against their skin. In another, they couldn't feel a soft brush swept across their palms or bottoms of their feet. Against hairy skin, the brush felt prickly. This struck Chesler and Bonneman as odd because most people report the brush feels pleasant. The scientists repeated their tests with the patients strapped into an MRI machine. They found that although healthy people's brains show activation in a region of the brain linked to experiencing physical sensation, that activation was missing in the young woman's and the girl's brains. Instead, when the researchers brushed the patient's hairy skin, the two showed brain activity in a different region linked to the emotional response to touch. They couldn't physically feel the brush, Chesler explains, but they experienced something like an emotional reaction to its touch. Finally, the researchers had the patients hold a device that slowly became painfully hot or cold. Surprisingly, the patients were just as good as the control group at determining changes in temperature and feeling pain. Tallying up the test results, Chesler and Bonneman determined that the piezo2 gene is likely critical for proprioception and sensing skin touch, but not for sensing temperature or pain. Though their study sample size of 2 is incredibly small, Chesler says he is confident the results shed light on the gene's role in the general population. It's all consistent with what we've seen in the animal models, and it just makes sense. There's no telling just how rare the mutation is, Bonneman adds, but now that he and Chesler have identified both its physical and genetic signature, he suspects they'll locate more people with the disorder. How piezo2 might relate to the patient's skeletal deformities is less clear. One possibility is that the proteins controlled by the gene play a key, as yet unknown, role in development. Another, Chesler and Bonneman note, is that proprioception itself might be necessary for normal skeletal development. Without it, the body can't hold a straight posture or orient its joints correctly, which could lead to abnormal skeletal development over time. I think these claims are provocative but indeed possible, says Ardem Patapushan of the Scripps Research Institute in San Diego, California, who led the previous piezo2 mice studies. An indirect role of touch or proprioception in bone formation is an intriguing and exciting possibility. Another intriguing possibility? The researchers speculate that different variations of the piezo2 gene might contribute to whether a person is klutzy, coordinated, or something in between. Could a finely tuned piezo2 gene contribute to superior athletic performance, or a poorly tuned one to clumsiness? Bonneman says, I think it's not impossible.